Our very last lesson in the unit on polynomials has us do complete factoring. And we also introduce a new style of factoring called factoring by grouping, which might initially look a little bit intimidating, but I find this to be one of the coolest types of factoring that we'll end up doing. I hope you agree. At first it's a little bit strange, like what am I seeing? I'll explain it to you and I hope I can make some sense of it for you. So this is for factoring four-term polynomials. So we're going to be factoring ax plus ay plus bx plus by. Now, to factor this, what we're going to be doing is grouping. And what we're going to group is the first two terms and the last two terms. Now, if you look at the way we've grouped this, if we notice in the first two terms, we can factor out an a. So we're going to factor out an a. And in the last two terms, we can factor out of both of those a b. So when we factor that a out, what's going to be left is a quantity x plus y. When we factor the b out of these, we're going to have plus, because there's a plus there, and we're factoring a b out, there's going to be a b there, and what's going to be left inside is an x plus y. I want you to stop and take a look that if we distribute this a through, and we distribute this b through, we end up with what we started with. So nothing's changed, we've just manipulated the way it's looking. Now this is where you have to look at this a little differently, okay? This plus is creating two terms, just like this plus created two terms. Now when we look at these two terms, we could see that there was a factor of a that we could factor out, and we did. That plus right there made us have those two terms, both of which had that factor of b that we factored out. Now that plus is making these two terms. Remember, terms are expressions separated by addition. So this expression and this expression are each terms because of that plus. Now, when we look at these two expressions, I think it should be kind of apparent to us that they both have an x plus y factor. Remember, a factor is an expression separated by multiplication. So both of them have that factor of x plus y. Just like these two terms had a common factor of a. A was a factor because it was separated by multiplication from the x and from the y with multiplication. So, just as we factor out an a, we can factor out this x plus y. So think about it. It's like a times fist plus b times fist. You can factor a fist out. Here, we're not factoring a fist because there is no fist. It's representing that x plus y. So that x plus y right here is being factored out of those two terms, which leaves us with a plus b. Now look, if I distribute this factor to a, I get a times x plus y. If I distribute that factor to b, I get b times x plus y. So the factored form of ax plus ay plus bx plus by is x plus y times a plus b. If you're thinking that this looks a little suspicious, like what? Seriously? I don't buy it. It seems way too suspicious. Well, we can check to see, does this produce that binomial or that four-term polynomial? And you'll see that it does. Let's use the extended distribution property, or FOIL. Well, let's use FOIL. First times first. First times first, x times a makes ax. Or xa, it doesn't matter, but I'm going to write ax. Let's do our outers. Our outers is going to make a plus bx. Let's multiply our inners. Our inners is going to make a y times an a, which I'm going to write as ay. And then our last times our last, our b times our y, is going to be plus by. Now look, we have an AX, we have an AX, we have an AY, we have an AY, we have a BX, we have a BX, we have a BY, we have a BY. You see that the product of those two binomials is that four-term polynomial. That's how you use factoring by grouping in this lesson. We're going to take a look at a few examples now.